Let's now take a step back and look at warehouses from a broader perspective. What roles do they actually play in supply networks? How do we differentiate one warehouse type from another? This slide shows a morphological box, a method used to systematically explore all relevant characteristics of a system. In this case, we're using it to describe and categorize different types of warehouses. Each row represents one category of characteristics, and each column shows typical values or expressions of that category. This is a helpful tool not only for analysis but also for warehouse design, benchmarking and communication. It helps structure complexity in a very visual way. Let's walk through this box from top to bottom and discuss each dimension. I'll explain what the terms mean in practice and give you examples along the way. We begin with the most fundamental question. What function does the warehouse serve? We talked about this in an earlier video, so I can keep this short. In some cases, a warehouse acts as a buffer. It absorbs mismatch between supply and demand. This could be a material buffer between a supplier's delivery schedule and the needs of a production line. A safeguard warehouse serves a similar purpose, but with a stronger focus on risk mitigation. For example, a manufacturer may keep critical spare parts in a safeguard warehouse to ensure production continuity in case of a supply disruption. Assorting warehouses play a very different role. They consolidate and prepare goods for downstream processes. You'll often find them in automotive or electronics assembly, where components from different suppliers are combined into kits. Also, the very common order picking in distribution centers falls into this category. In speculative warehouses, inventory is held in anticipation of future demand. These warehouses play a role in hedging against price changes or seasonal shifts. Think of retailers stocking up on heaters in summer before the winter sales spike. Lastly, refinement warehouses go one step further. They are typically located near the customer and may include value-adding services like ripening, customization, labeling, or late-stage assembly. The second row classifies the warehouse according to its position in the supply network. A warehouse could be located close to the source, at our supplier, or more generally, at a supplier of the company of interest. The warehouse could also be an inbound warehouse for the focal company's customer, holding input material for the customer's production process. The term customer WIP stands for work in progress. These are intermediate warehouses inside or near the customer's operations, especially in complex or multi-stage production processes. Customer FGI stands for finished goods inventory at the customer site. These are products that have been completed and are waiting to be distributed. And finally, we have customer distribution centers, which are typically used to serve stores, branches, or end consumers directly. A classic example would be the large retail distribution centers run by supermarket chains. The third row shows the warehouse's role within the value chain. Some warehouses are clearly part of inbound logistics. Their role is to receive, sort, and temporarily store incoming materials. Others hold overstock, products that are not currently needed in production or distribution, but are kept for future use. These may be slow movers, seasonal items, or goods awaiting a change in demand. Warehouses that serve production are usually tightly integrated with manufacturing processes. They may store semi-finished goods, kits, or line-side materials. Outbound warehouses prepare and dispatch goods for delivery to customers. This is where picking, packing, and shipping take place. And then we have returns warehouses. These are essential in industries with high return rates, such as e-commerce, where returned goods must be checked, sorted, refurbished, or scrapped. We'll talk about return warehouses a bit more in a short while. Next comes the degree of centrality. In other words, how central or regional the warehouse location is. Central warehouses serve multiple regions or even countries from one site. They benefit from economies of scale and centralized inventory control, but usually involve longer transport distances to the final customer. Regional warehouses are closer to the point of use. They enable faster response times and more flexible deliveries, but require more stock to be spread across multiple locations. Many companies use a hybrid model, a central warehouse for slow movers and bulk stock, and regional hubs for fast movers and daily operations. We now move on to weather protection. Most warehouses are, of course, located indoors, offering full protection from the elements. However, outdoor storage is still widely used, particularly for construction materials, bulk goods, or items that are not sensitive to rain or sun. Outdoor areas must be carefully managed with regard to drainage, security, and legal constraints. Temperature is another parameter. Most warehouses operate at ambient temperature, which means no heating or cooling beyond general building climate. For food, pharmaceuticals, and certain chemicals, temperature control is essential. Fresh storage typically means temperatures between 2 and 7 degrees Celsius. This requires insulated walls, airlocks, and constant monitoring. Deep freeze storage is even more demanding. Think of minus 18 degrees and below. These warehouses are energy intensive and require special floor and wall construction. They are also difficult to operate manually due to the cold, and they are expensive to automate. Let's talk about storage media, meaning the physical format in which goods are stored. Pallets are the standard in many industries, especially for bulk or heavy goods. They're easy to handle with forklifts and compatible with racking systems. Plastic totes are used mainly in small parts handling. They are standard sized, work well in automated environments, and protect contents from dust and damage. Cartons, usually corrugated cardboard boxes, are common in manual picking and e-commerce. They are lightweight and cheap, but less durable. In some environments, items are stored and picked individually. For example, in spare parts warehouses or pharmaceutical logistics, where each blister pack or component is treated as a separate unit. Now we come to the topic of management. In self-managed warehouses, the owning company handles all operations. They decide what to stock, how to run processes, and what systems to use. In vendor-managed inventory, the supplier takes responsibility for keeping the warehouse stocked. This requires close data integration and trust between supplier and customer. In consignment models, the goods are physically located in the warehouse, but the supplier retains ownership until the goods are used or sold. This reduces working capital for the buyer at the expense of the supplier. That's a very common model in buyer-supplier relationships, where the buyer is significantly more powerful than the supplier, as it often is the case in the automotive industry. And finally, 3PL warehouses are operated by third-party logistics providers. The provider handles storage, handling, and sometimes transport on behalf of the client. This model offers flexibility but requires well-defined contracts and service-level agreements. Client structure is an aspect of 3PL warehouses and refers to whether the warehouse serves one or multiple clients. Single-user warehouses are dedicated to one company. They can be optimized for specific processes and usually have less complexity. Multi-user warehouses serve several clients at once. They are not as common as one might think, but they are becoming a more common model for third-party logistics providers. The last category on this slide is storage structure, the physical arrangement of storage within the warehouse. Block storage is the simplest method. Goods are stacked on the floor without racking, usually in lanes. It's space efficient but limits accessibility. Stacked rows build on that idea but offer a bit more order. Pallets are stacked 2 or 3 high, typically sorted by SKU or customer. Static racking introduces defined positions. This is ideal for picking operations or when goods vary in size and volume. Mobile racking systems allow racks to move on rails, opening only the aisle currently needed. This increases space utilization but adds complexity and, of course, installation cost. High bay racking refers to tall racking systems that often reach up to 20 or 30 meters. These are typically accessed by stacker cranes or shuttles in fully automated systems. And finally, we have flow racks, also called dynamic racks, which use gravity to move goods toward the picking phase. These are ideal for first in, first out inventory handling and are common in food distribution and production supply. As you can see, this morphological box offers a very structured way to think about warehouse design. And every choice in this box has implications, not only for layout and equipment, but also for staffing, automation, IT systems, and overall supply chain performance. In this course, we'll keep coming back to this structure as we analyze different warehouse types, technologies, and real-world case studies.